This is the second video of two showing how to solve the 67K challenge from EasyCTF, which just ended yesterday. And so in the first part, there were 67,000 Windows executables, which you had to run and play a game and win the game, and then you would get a reward of one character. And I showed how to patch that so you could, in Ollie debug, and then run a Python script to repeat it 67,000 times. So you get all these characters, J, A, V, A, and all the characters end up into this stuff here. And this stuff is pretty hard to read. Now, my first thought was that this stuff was brainfuck, which is a famous esoteric language containing nothing but punctuation marks. But one of my students figured out what it is. This is not brainfuck. This is JSfuck. Now, JSfuck is something that actually has some use for penetration testers to conceal JavaScript in such an obscure way that it goes past intrusion detection systems on networks and other defenses. And here's how it works. If you take alert 1, you can turn it into this garbage here, and all that garbage you can run in JavaScript. If you view developer JavaScript console, you can put a line of JavaScript here and execute it, and if you do, it pops up alert 1. So it works, and the reason this stuff works is explained down here and in the references. Brackets define a variable of some sort. Not is the opposite, so now it's false. Not becomes true. You can then get numbers by adding to it and so on. So with nothing but these punctuation marks, you can very slowly build up working code character by character, but it's extremely lengthy. Hundreds and hundreds of these punctuation marks for every character you make. All right, so what we have to do is evaluate this stuff. So the first thing you might try, of course, is to just run this stuff. So you go to your JavaScript console, paste in that long junk, and run it. And what you get is a syntax error, unexpected token. There's a link you can click here for a little more information, but in this case, it doesn't really give you any more information, but you might notice that there was an extra JavaScript at the end there. So if you go back to the original code here and go to the end, indeed, there's a second JavaScript down there, which looks kind of funny. And I wondered what that was for, or if there were somehow two stages of the code or something, but I eventually figured this out. If you just copy that whole thing and search for it, that whole thing is equal to the start of the file. The start of the file is an exact match for the end of the file. The file repeats, and you just don't need that second piece. I just deleted it. Now, I'm going to make another file. I've always learned to do this when solving puzzles or doing exploit development or anything that involves many steps, is to always save every step I have and make a new file for the next step. So I'm going to call this I'm going to call this flag1. All right. So this is my first attempt to clean it up. So now I've gotten rid of that extra JavaScript statement at the end that was fouling me up. So let's try running this one. Go down to here, go back to the console, and run this one. And it doesn't even run. It just acts like it's expecting more input. And if you take a look, that's kind of obvious why. I have an open parentheses here that's not being closed. So this is obviously a fragment of JavaScript, not the whole thing. I'm just going to close the console entirely in an attempt to clear it. And let's go down here and try to figure out how to cope with this. I need to add stuff to the end. Now, I did try adding the right punctuation marks to the end, and it wasn't that simple. But first, let's figure out how to find out what the right punctuation marks are. I don't know if I need a parentheses or perhaps if there are other unmatched characters back here. So to figure that out, I made a Python script called parse. So let me open it up here. Good, there's parse. All right, all this thing does is you use it by saying parse file name, then it opens that file and reads characters one by one. And if they are opening a container with a bracket or a parentheses, it adds it to a thing called prefix. If it's closing, it warns you if it closes with the incorrect character. If it closes with the correct character, it just shrinks the prefix. So it's not a very complicated program. And if you run it here, I'm going to try test file first. So cat test. And you see I made the test file is just a series of containers that match. 3 parentheses, 3 brackets, open, close, close the brackets, close the parentheses. So that's a very simple example to test the parse file on. So if I parse test, here's what it does. I'm in deeper, then I'm getting back and forth, then I clean up, and I end up with a line that's completely empty, meaning everything is matched. So that would be the logical end of the file. All right, so that's how parse works. So let's run parse on my flag 1. Okay, it's much longer, of course, and it goes on, going down and up and down and up, but it ends here at 65535, and at this point, it is still 6 layers deep in nested containers. So that is important information, and I stuck it over here in the corner so I can refer to it as needed. I'm just going to move this off. All right. So that's the number of characters in the code I was able to recover, and this is the condition you end up in, that many layers deep. So I need to somehow find something to add to the end that has this pattern of unmatched container markers. And there's another thing about this JS fuck stuff that is worth knowing, and that is that it is very, very repetitive. If you take any string, you'll find many, many occurrences of the same string because, in fact, this is not random at all. In fact, there are just certain very long strings of maybe 100 characters that add up to some letter you want to use, like A, and that letter will appear over and over. So we can probably find the right terminator here by finding an earlier occurrence of this string. So I'm going to copy this and make another one, call it flag 2. And then I'm going to go to the end, and I'm going to pick some portion of this to be my indicator. I'll just pick some characters, and then I'm going to go to the end and put in a couple more character turns. So let's see where else this string occurs. If I just go up, it occurs right there. So if I assume that this is a repeating string, then if I add some more of it, say down to here, and just copy it and paste it down here, then I might have just terminated it correctly. You've got to see. One thing, however, is that this part is now repeated. That is exactly repeated here, and that's going to foul everything up, so I'll delete one of these. All right, there is my candidate, so let's save that as flag 2, and let's parse flag 2. All right. Now, flag 2, remember this is the part that I know was good, up to 65535, so let's scroll back to there. So here I am, and as I go ahead, the containers go deeper, shallower and deeper, shallower and deeper, but they never actually get all the way down to the bottom. So I don't think this is the right answer, and in the past I've tried using longer strings of it, and even though I was able to find a string that got pretty close to matching, it wasn't a useful answer. So I'm going to forget about this one. Let's make another copy of this one and call it flag 3. NVS flag 3. And let's pick up by repeating what we had. We'll take some stuff at the end here and put in some character turns to organize it. I'll hunt for other occurrences of this. Remember, the 1 back did not work, so I'll just go for the 1 2 back. All right, and then I'll add some more stuff. So I have that followed by some more characters after it. All right, and I pasted it here, and again, this whole string duplicates that whole string, so I delete one occurrence of them, and now I've got my candidate for parsing as flag 3. So parse flag 3. All right, now eventually I have a mismatch, so hopefully that's after I've gotten where I need to get. And if I want to start at 65,535 here, and you see it gets down to 3 layers down, 3 layers down, and right here it gets as close to 0 as I was ever able to get, which is down to just 1 open parentheses down at 65584. So now I just want to delete everything from that point on. Now I have the characters here, and I can sort of match them one by one, but who has the patience for that? I can see there's at least 10 or 15 of them, so let's delete a bunch of this junk there. Save it again, parse it again, and see how close I am. Okay, there's the spot where I'm 1 down. I still need to remove what looks like about another 10 characters. So let's take it back to here. There, and there I ended at a parentheses. That looks like that might be the right place to stop. Parse it again. That is the right place to stop. Now I'm one parentheses in. So I'm going to guess, I can just put a parentheses there, that this whole thing was in some kind of container that was not used by the code I copied. That seems like the only thing I could do. So let's get rid of all these extra carriage returns. All right, save that as my flag 3. And now if I go to my browser and view the developer JavaScript console again and paste in that stuff and press enter, now it says invalid or unexpected token, but if you click this thing, it's not perfectly fixed, but it is fixed enough that you can see the flag. So that's what I wanted to show you. This is how you can fill in the gap that was lost there, even without really understanding what was going on. The only thing I used to do this was the fact that the tokens must match. An opening parentheses must find a closing parentheses, and an opening bracket must find a closing bracket. So that's what I wanted to show you. And I'll quit this and call it 67 Part 2.